We were discussing about the topic of the radioactivity, and it is in continuation to the previous lesson. So, the exponential nature. So, every radioactive decay is having what nature? Exponential nature. And exponential is graph is always being drawn or shown with respect to what? So, let's say this is time, and there is n number of remaining nuclei. So, with the passage of time, these remaining number of nuclei are decaying, and they are decaying in what manner? They are decaying exponentially. Uh, so if we are having the slope a much steeper, like you can see in this specific graph, this shows that its decay constant is larger. And if its decay constant is larger, what does this means? This means that there is going to be high activity, more number of nuclei are going to disintegrate in a shorter time. Like radioactivity is going to be quicker. But if there is going to be a smaller decay constant, like the value of lambda is small, what will happen in this specific case? This shows that less number of nuclei will disintegrate or decay in a time, in a respective time. So you must be knowing about this exponential decay. And whenever we are representing anything which is decreasing exponentially, we are always using the function of e. So e power x function is actually representing an exponential, either an exponential increase or an exponential decrease. So if there is an exponential decrease, so there is always an e raised to power minus x. And E is a constant value, 2.713 and so on and so forth value. So let's see how mathematically we are going to represent the mathematical nature of the radioactive decay. So mathematically, what is the formula representing the radioactive decay? That n, n stands for remaining number of undecayed nuclei, कि कितने अभी ऐसे न्यूक्लियाई रह गए हैं जिन्होंने डिके होना है. What is n naught? N naught is the initial number of undecayed nuclei. Then E is an exponential function. Negative shows that it is decaying. What this lambda is called as decay constant, which we just studied previously. Decay constant. And what is T? In how much time the nuclei are decaying from one number to another number. So the general equation for the radioactive decay is what? X is equals to x naught e power minus lambda times t. Whereas ये जो x है, x में क्या कुछ आ सकता है? X can represent either as nuclei number. X can be used for representing activity, and X can be used to represent the count rate. Do you remember count rate being shown on the Geiger-Müller tube? So count rate भी कम होता जाता है with the passage of time. तो अगर हम इन radioactive decay में देखें, तो जो remaining number of nuclei हैं वो भी exponentially decay कर रहे हैं, जो activity है वो भी exponentially decay करेगी, जो count rate है वो remaining count rate वो भी exponentially decay करेगा. So as per this phenomena, we are going to have three equations representing any of the radioactive decay. और वो तीन equations क्या क्या हैं? The very first equation is shown here, which is written as well. मैं दोबारा लिख देता हूँ. N is equals to n naught e power decay constant into time. This is one of the equation. Second equation in terms of activity is what? A is equals to A naught e power minus lambda of t. And third equation is C. C stands for count rate. C is equals to C naught e power minus of lambda t. So the symbol e represents the exponential constant and its value is around 2.718, and it can be on a calculator, it can be seen with a function or value of e power x. Are you understanding? Yes, students, are you with me? Hello, people, are you with me?
Yes, sir.
Are you understanding?
Yes.
Is there any question? क्या मैं आगे चलूं? Yes, please speak up. Shall I move on?
Yes, sir.
All right. Moving onwards, what's next is there. Okay, let's see how one any of the formula which is given with respect to the radioactive decay can be used in an example. So do remember the application of these formulas do appear in your exam and how to cater the calculation related to it. So let's see. So question says that there is a strontium 90. It decays with the emission of beta particle to form yttrium. तो यही हम पढ़े रेडियो एक्टिविटी में हो क्या रहा है कि वन ऑफ एन अनस्टेबल न्यूक्लियाई is converting itself into a more stable form. Question says that this strontium is having a decay constant of how much? It is having a value of decay constant as 0.025 per year. Then question says determine the activity A of the sample after 5 years, expressing the answer as a fraction of the initial activity A naught. तो इसमें बात एक्टिविटी के पॉइंट ऑफ व्यू से हो रही है. So we know simply that what formula we are going to use in this specific case, A is equals to A naught e raised to power minus lambda t. Now I am pretty aware it is saying determine the activity A in terms of A naught. ठीक है, यानी कि हमें A naught और A की वैल्यू नहीं बताई हुई, हमने इसके इसके ही फॉर्म में we have to answer it out. So now what this will become as A is equals to A naught e raised to power minus, what is lambda here? The 0.025 will be called as lambda. So instead of lambda, we are going to write what? 0.025. We are not going to convert at the moment this year into seconds. Why? Because here the time given is also in years. But if the time would have given in seconds and here it would have been in years, or here if it is in seconds or here it would have been in years, so then we would have do a necessary conversion. So time कितना हमें दिया हुआ है? It is 5. So we need to find out the answer. So it will be A divided by A naught, which will be equals to E raised to power minus of 0.025 into 5. So at the end, what will be our result? It will be approximately equivalent to 0.88. So this is going to be the answer. And what does this shows? This shows only 12% of the activity. Yeah, the activity of the strontium decreases by 12% of its initial value after 5 years. तो कितनी एक्टिविटी कम हुई, कितना डिकेइंग रेट कम हुआ आफ्टर 5 years? Almost 12%. Yes, student, is this understandable? Ji, please speak up.
Yes, sir.
Have you noted? Shall I move on? Yeah, shall I wait?
You can move on, sir.
Okay. Next is the concept of half-life. Now it is very pretty important to understand the term half-life, what actually it means. So let me try to express and explain what it actually means. For instance, we are having one of our radioactive sample. What I am having with me? I am having one of the radioactive sample. You can consider as a one sort of as an example, in the form of example or an analogy, that I am having one bag. In that bag, I am having multiple radioactive nuclei present in it. It can be of any number. Let's say in one of the sample I was having 1,000 nuclei of radioactive sample, right? How much, and we are continuously studying any of the element which is radioactive, it is changing itself. It is continuously decaying. It is continuously deteriorating. It is continuously finishing and is converting into some other form of elements. Is it so? So what will be happening? How much time will be taken by these 1,000 nuclei to convert themselves into half of its value? कितना time लगेगा for the number of nuclei, the initial count of number of nuclei, to reduce to its half of a value? This time is called as half-life. This time is called as half-life. नाम से पता चल रहा है half-life. ऐसा time कि जिसमें initial number of nuclei in a given radioactive sample, they reduces to half. They reduces to what? They reduces to half. That is known as half life. Likewise, there is going to be some further time taken by 500 to reduce to what value? To reduce to 250. It means the time which is taken to reduce from 500 to 250, it will be same as the initial time. So we are going to say it as second half life. So there will be first half life, there will be first half life, there will be second half life. There will be first half life, there will be second half life. Then this 250 will be further disintegrating and the remaining will be 125. So it will happen after third half life. And this procedure is going to continue till the radioactive sample or substance sustains. Yes, is the concept of half-life understand is absorbable, is digestible? Yes, students, are you with
Yes,
me?
sir.
So how much time is taken by the number of nuclei in a given radioactive sample to reduce to its half value? That time is called as half-life. That time is called as half-life. So how we are going to define this half-life? तो आप इस जो डेफिनेशन ये वाली लिखी हुई इसको थोड़ा सा इम्प्रूव करेंगे आप. Write down the definition for the half-life which Cambridge demands. The time taken, the time taken by the initial number of nuclei present in radioactive sample present in radioactive sample to reduce to half. The time taken by the initial number of nuclei present in a radioactive sample to reduce to half is known as what? Is known as half-life. It will be called as half-life. The time taken by the initial number of the nuclei present in a radioactive sample to reduce to its half value will be called as half-life. So let's say if my initial count rate was n naught, after one half-life it will be remaining what? N naught by 2. Then after another half-life it will be remaining as n naught by 4. Then another half-life it will be remaining as n naught by 8. So this half-life is also following what? It is following an exponential decay. And we have studied the formula A is equals to lambda n, whereas lambda is constant. So we can say that activity is proportional to number of nuclei remaining in the sample. तो उसको हम graphically कैसे बना सकते हैं? If number of nuclei is also reducing to half after a half-life time, then activity we can also say then activity can also be reduced to half after the time of half-life. So after the time of half-life, the activity is reducing to the half value, and that time is known as half life. तो उसको हम ग्राफिकली कैसे बना सकते हैं कि लेट्स से इनिशियली हमारे पास एक्टिविटी मैक्सिमम एक्टिविटी है ए नॉट, तो एक हाफ लाइफ के बाद वो कितनी रह जाएगी? इट विल बी रिमेनिंग एज ए नॉट बाय 2. देन आफ्टर सेकंड हाफ लाइफ वो कितनी रह जाएगी? ए नॉट बाय 4. देन आफ्टर थर्ड हाफ लाइफ इट विल बी रिमेनिंग एज ए नॉट बाय 8, and this continues till the activity stops. So activity dropped by half of the value, and then activity drops by quarter of our initial value. So is the concept of half-life clear? Yes, student, please speak up.
Yes, sir.
Okay, moving onwards to the next part. Now we are going to derive the formula for half-life. And in exam, you can get a question related to it, like deriving the formula for the half-life and how it can be done. So let's see. We know that a radioactive decay equation is what? The radioactive decay equation is n is equals to n naught e power minus of lambda times t, right? And we can say that after the time of फर्स्ट हाफ लाइफ, यानी कि जब हमारा टाइम हाफ लाइफ के बराबर होगा, इतना टाइम गुजर गया कि आपके रिमेनिंग नंबर ऑफ एटम्स जो है वो हाफ हो गए, तो कैन वी से दैट n विल बिकम एज व्हाट? हाफ ऑफ इट्स इनिशियल वैल्यू. जी बेटा, ये बात बताएं, क्या ये समझ आ रही है कि लेट से मैं कहता हूँ जब मेरा टाइम जो है वो हाफ लाइफ के टाइम के बराबर हो गया, ठीक है, टी हाफ क्या रिप्रेजेंट कर रहा है? इट इज रिप्रेजेंटिंग, सॉरी, what t half is representing? T half is representing a time of a time of half life, a time of half life. एक हाफ लाइफ के बाद जो इनिशियल नंबर ऑफ एक हाफ लाइफ के बाद जो आपके पास रिमेनिंग नंबर ऑफ न्यूक्लिया है वो इनिशियल के क्या हो जाएंगे? हाफ. एन नॉट क्या है? एन नॉट इज इनिशियल नंबर ऑफ न्यूक्लियाई. एन नॉट इज इनिशियल नंबर ऑफ न्यूक्लियाई. So remaining number of nuclei is equals to n naught e power minus lambda times t. So after a time of half life, the remaining number of nuclei will be equivalent to what? It will be equivalent to half of the initial value. तो अब देखो मेरे पास ये इक्वेशन किस तरह रीफ्रेम हो जाएगी. कैन आई राइट इट एड इन दिस वे दैट n इज इक्वल टू एन नॉट. मैं ये फर्स्ट इक्वेशन में प्लग इन करता हूँ. सो n नॉट ओवर 2 इज इक्वल्स टू n नॉट e पावर माइनस lambda times t. This n naught and n naught cancels out. This will becomes what? 2 is equals to e power minus lambda t. अच्छा ये 1 मिनट का सेशन रह गया है. अगर ये बीच में डिस्कनेक्ट हुए थे तो प्लीज आपने रिकनेक्ट करना है, रीजॉइन करना है. ठीक है. So this will becomes what? 1 over 2 is equals to 1 divided by e power lambda t. ऊपर नेगेटिव था, नीचे पॉजिटिव हो गया. अगर हम क्रॉस मल्टीप्लाई करें तो ये क्या बन जाएगा? e power lambda t is equals to 2. If I want to get rid of e, I'm going to take natural log. नेचुरल लॉग लेंगे दोनों साइड के ऊपर. मैंने आपको ये नेचुरल लॉग वाली बात पढ़ाई हुई है. तो ये आपके पास किसके इक्वल आ जाएगा? दिस विल बी इक्वल्स टू, अब लेमडा